Now we are going to be learning about nomenclature of amines. The learning objective for this video is to name amines as we will be learning about amides in another chapter. And we're going to be following IUPAC nomenclature rules. So IUPAC for primary amines, and then we'll talk about secondary and tertiary amines soon. Often when we draw our amines, we kind of envision them with the N being center, like this. But when we are viewing our molecule, we have to imagine that we name the longest parent chain and then indicate where the nitrogen is coming off. So for instance, this molecule has 2 carbon chain, and so that is ethane. The suffix for an amine is amine. So we erase the E. Make sure you keep the AN there because that's a syllable that we got to make sure we keep. That means single bonds. And we change the suffix to amine. So this is ethanamine. It's coming off of the first carbon, and so normally we would put a 1. But since no matter which carbon we have that nitrogen coming off of, like if it was coming off of this other carbon, this carbon would be number 1 now. And so no matter where this carbon is attached in this particular molecule, it's going to be a number 1. There's no isomers possible. So we'll admit the 1 in that name. Let's look at this molecule. This molecule has a 4 carbon long chain, and so that is butane. The suffix for an amine is an amine, and so we change that to butanamine. And then we indicate where that nitrogen is located. And we're trying to minimize numbering here. And so if we number from this direction, that amine can be classified as a number 2 on the number 2 carbon. And so this molecule is 2-butanamine. For secondary and tertiary amines, we follow similar rules to our primary amine, meaning that we are trying to name the parent chain and then substituents off of it. However, secondary and tertiary amines have more than 1 carbon chain connected to the nitrogen. You're going to be picking the longest carbon chain that's attached to the nitrogen for your parent name. Any other carbon chain on that becomes a substituent on the nitrogen. And so, for instance, this molecule here, we have this carbon chain, and we have this carbon chain off of that nitrogen. And so this is going to be our parent chain because that has the most carbons. And so that's going to be propanamine. It's off of the second carbon in that chain, and so we'll put a 2 there. So that's 2-propanamine. What about this other carbon? This other carbon is attached to the nitrogen. And so rather than putting a number, we're going to write an N, meaning it's attached to the nitrogen. And so this is N-methyl 2-propanamine. This N here is treated just like a number. That means that if there's more than 1, then you could do 2, N or whatever, or 2, N dimethyl. Like you can treat it just like it was a number. If there's more than 1 substituent on the nitrogen, then you're just going to alphabetize them. Those same nomenclature rules we learned before are still taking effect. When we name aromatic compounds with an amine, then aniline is the root word that IUPAC is okay with. So this is aniline, and this carbon here would be numbered 1. Then we would number with respect to that being carbon number 1. So here we have our aniline root. That's number 1, 2, 3, 4. And so that's 4-nitroaniline. This one is 3-methylaniline. And this one has a carbon group also attached to the aniline. This is ethyl. And so this is N-ethyl aniline. Where do amine groups fall in our functional group priority for suffix? Amines are very low on the priority list for suffix. They are below alcohols. That means if there's an alcohol and an amine group in your molecule, it is named like it's an alcohol. The amine would get thrown into a prefix. And so as a prefix, it is amino. Think of like amino acids. They will have both an amine functional group and a carboxylic acid functional group. Carboxylic acids are higher priority though, so it's known as an amino acid, not a carboxylamine. Let's practice naming our molecules and drawing their structures. This is 4 different problems here. So go ahead and name these 2 molecules and draw these 2 molecules in your notebook. Unpause the video when you're ready to check your answer. Okay, so for our first one, this is a primary amine. And so we have to think about what's the longest carbon chain attached to this nitrogen. Obviously, it contains this carbon here. Now, you might have named it 1, 2, 3 with a methyl group off of this carbon, but really this is a 4 carbon long chain. 1, 2, 3, 4. And so that's butanamine. This nitrogen is off of the second carbon. It's closer to that end. So that's carbon number 1, that's carbon number 2. And so that is 2-butanamine. This molecule is supposed to be N,N-dimethyl cyclopentanamine. So pent means 5, cyclo means cyclic. So I'm going to draw a pentagon. So I got my pentagon. And then it says N,N-dimethyl. Where is my amine group? The amine is not part of the ring. We are given 2 methyl groups off of the nitrogen. And so there's a methyl group here and a methyl group here. And so this is not part of the ring. The parent chain is cyclopentane, and that is attached to the nitrogen. Now let's talk about this molecule over here. What would this be named? Well, we have to find our longest chain so that we can get our parent chain. This is the longest chain that has 2 carbons, and so that is ethanamine. And then the other 2 carbon chains are methyl groups. And so that is N, N dimethyl. Make that H better. Dimethyl enthanamine. This is 3-chloroaniline. Aniline is the aromatic benzene ring with an amine group on it. So that's aniline. This says 3-chloro. So that must be carbon number 1, 2, 3. 3-chloroaniline. Let's do some more practice with a little bit more complicated molecules. Go ahead and pause the video and try to work out the names for each of these. All right, let's go over this. So we need the longest chain for this. This has 1, 2, 3, 4, 1, 2, 3, 4. So either way, we have a 4 carbon long chain attached to our nitrogen. And so that is going to be butanamine. Let's go ahead and identify this direction as our parent chain. And then we're going to call that number 1 and that's going to be number 2. Off of the second carbon, we have an ethyl group. And so it's going to be, well, we got to remember to put an N, not an N, but we'll put a 1 there for butanamine. And that's a 2-ethyl. So it's 2-ethyl, 1-butanamine. Now for our next molecule. This is an aldehyde. That means this is going to be in the prefix as amino. This has 1, 2, 3, 4, 5 carbons. That's going to be propanal. Not propanal, pentanal. 1, 2, 3, 4, 5. That's pentanal. That's pentanal. That's carbon number 1, 2, 3. And so off of the third carbon, we have an amino group. So that's 3 amino pentanal. Now we will draw 5 amino 3 hexanol. Hexanol, it doesn't say cyclohexanol. This is just a straight chain. 1, 2, 3, 4, 5, 6. So we got our 6 carbons. 3 hexanol means off of the third carbon, 1, 2, 3, we have an alcohol group. Off of the fifth carbon, we have the amino group. 1, 2, 3, 4, 5. So notice how we're minimizing the numbering of this alcohol group because that's a higher priority suffix. So that's our suffix, and then we're minimizing its numbering. Now we have to draw this other molecule. This is 2-pentanamine. So it's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then off of the second carbon, we have an amine group. Then we have something off of the amine group. We have a methyl group off the nitrogen. We also have a methyl group off the third carbon. So that's number 2. This would be number 3. So that's another methyl group. And then off the fourth carbon, we have a chloro group. Here's another practice problem for you. Which of the following is a skeletal isomer for 1-butanamine? Go ahead and pause the video and work this out. All right, so what does skeletal isomer mean? Skeletal isomers have different arrangements of the carbon. Right, different carbon skeleton. Isomer, though, means same molecular formula. So how many carbons are in our molecule? Butanamine should have 4 carbons, so we're looking for 4 carbons total in our molecule. That means that 1-pentamine is completely not logical. That one has too many carbons. 2-butanamine is going to be a functional group isomer, or it's going to be a positional isomer, sorry. That's a positional isomer. Because it has the same name but a different location of the functional group. So that's a functional group isomer. 3-butanamine is actually just a bad name because that's going to be 1, 2, 3, 4, but 1, 2, 3. This is really 2-butanamine, which we decided was a positional isomer. And then we can rule out both A and C because both of those are positional isomers. So we're left with 2-methyl, 1-propanamine. Methyl means 1 carbon, propan means 3 carbon, so it does have 4 carbons total, what we are expecting out of our structural isomer. But our parent chain is different. And so even if we didn't know how to eliminate these other ones, at least part D did make sense.